Welcome back, everyone. Today we're tackling a genuinely fascinating challenge in the world of artificial intelligence. Now, you've likely seen what a standalone AI can do. It's impressive, right? But what happens when you need it to do, well, more? What if you need it to know your company's proprietary secrets, actually perform accurate math, or browse the live, real-time internet? Well, today we are demystifying LangChain. It's an absolutely incredible framework designed specifically to help you overcome the limitations of standalone AI so you can build powerful custom LLM applications. I want you to think of LangChain like a box of highly modular building blocks. We're going to stack them together to build something truly remarkable.
Okay, let's dive into this blueprint. Today's explainer is broken down into 5 key areas. First, the standalone LLM problem. Second, linking ideas with chains. Third, building the application. Fourth, empowering AI with agents. And finally, giving your AI memory. All right, section 1, the standalone LLM problem, looking at the limits of standard AI. To really appreciate the solution here, we first need to look at the roadblocks businesses hit when they just rely on foundational models. There's honestly a massive gap between standard AI capabilities and real-world business requirements. Think about a standalone application like standard ChatGPT. It's kind of static, right? It has a strict knowledge cutoff. For the source material we're looking at, that's September 2021. But more importantly, it has absolutely zero access to your internal organizational data. If you run a business and ask the AI, hey, how many employees joined our team last month? It literally can't answer you. Plus, every single API call you make costs money based on tokens. Contrast that with dynamic business needs. You need live Google search data. You need access to your specific company databases. And you absolutely must have budget control so your startup doesn't just burn through all its cash. So the crucial point to understand is this. Foundational API providers, like OpenAI, they're focused on the core models. They leave the actual application building up to us. And that is exactly where LangChain comes in. LangChain is basically the ultimate solution to these roadblocks. It's a plug-and-play framework that acts as a bridge. It connects foundational APIs, whether that's OpenAI or an open-source alternative like Hugging Face, right directly to your specific proprietary data. It's what lets your AI seamlessly integrate with the outside world. Moving right along to section 2, linking ideas with chains, where we'll look at utilizing prompt templates. Now that we know what the framework actually does, let's look at its most foundational concept, which is, appropriately, chains. A sequential chain perfectly illustrates an automated assembly line. Let's say you want to build a restaurant idea generator. You definitely don't want to type out a full, complex prompt every single time. Instead, you create a chain. Step 1, you just input a variable. Let's go with a food cuisine, like Mexican. Step 2, the model takes that and generates a fancy restaurant name, say Taco Temptation. But here's where the magic of the chain happens. That output instantly and automatically becomes the input for step 3, where a completely different prompt asks the AI to generate menu items specifically for Taco Temptation, popping out things like quesadillas and burritos. So one single input from you triggers this entire cascade of automated AI tasks. Which brings us to section 3, building the application and creating streamlined apps. Now, it's one thing to have some cool code running in the background of your terminal, but how do we actually bring these chains to life for a normal user? This is where we pair LangChain with incredible tools like Streamlit. Streamlit is a library that lets you wrap all your LangChain logic into a highly functional web application in, I'm not kidding, mere minutes. You don't need to know complex front-end frameworks like React. With just a few lines of code, you can build a working proof-of-concept app. We're talking interactive sidebars, drop-down menus to select your cuisine, and clean visual outputs for your generated names and menus. It literally brings the power of your LLM chains straight to the user's browser. Next up is section 4, empowering AI with agents, where we start building reasoning engines. Guys, it's time for a major aha moment. This is where we shift from treating AI as a simple knowledge engine to treating it as a powerful reasoning engine. To really grasp why agents are so revolutionary, consider this specific question. When was Elon Musk born and what is his age in 2023? A standalone LLM will actually struggle with this. Why? Well, because of its knowledge cutoff, it might not confidently know the current date. And surprisingly, standard large language models are actually notoriously unreliable when it comes to performing basic mathematical calculations. And this brilliantly illustrates exactly where agents step in to save the day. An agent essentially hands the AI a utility belt of plug-and-play tools, so it can go out and fetch the information it's missing. Just look at this list. It can tap into Wikipedia to verify historical birth dates. It can use the SERP API to run live Google searches, so if you asked it for the 2022 US GDP, it could actually go find it. It can route math problems straight to an LLM math calculator tool so you get 100% accuracy, or, believe it or not, it can even browse Expedia to fetch live flight tickets and pricing.
Let's look at exactly how an agent mimics human reasoning to solve that Elon Musk problem using what's called the REACT, or Reasoning and Acting Framework. Step 1, the AI has a thought. It literally realizes, wait, I don't know his age, I first need to find his birth year. Step 2, it takes an action. It autonomously grabs the Wikipedia tool, searches his name, and extracts the year 1971. Step 3, another action. It reasons that it needs to subtract 1971 from 2023, so it sends those numbers over to the LLM math tool, which flawlessly returns 52. The AI reasoned through its own knowledge gaps and used external tools to bridge them step by step. It is absolutely brilliant. Finally, we reach Section 5, giving your AI memory and maintaining conversational context.
So, we have chains, we have web interfaces, and we have reasoning agents. But to make these applications truly conversational, we have to give the AI a memory. Because, by default, LLM chains are completely stateless. Honestly, they're like goldfish. If you ask an AI, hey, who won the first Cricket World Cup, and it answers you, and then your very next question is just, who was the captain, the AI will completely forget the context of the sport. It won't know if you're talking about cricket, football, or a local debate team. Every single prompt is a blank slate unless we explicitly build a memory structure for it. LangChain gives us a few different ways to solve this, but you have to be highly strategic here because of the cost implications. A conversational buffer memory remembers absolutely everything. It saves 100% of the chat history. Now, this is fantastic if you need to save, say, legal transcripts for a customer service chatbot, but the cost impact is pretty brutal because OpenAI charges you per token. Sending that massive, ever-growing history back and forth with every message causes your API bill to spike rapidly. The alternative is something called a window memory. By setting a parameter, let's say k equals 1, the AI only remembers the single most recent conversational exchange. It is highly optimized, it absolutely protects your budget, but it does intentionally cause a sort of short memory loss for older parts of the chat. So as the developer, you have to choose the perfect balance. We've seen how LangChain acts as the ultimate set of building blocks, bridging that crucial gap between basic standalone models and dynamic real-world utility. Which leaves us with one final incredibly exciting thought. By combining the problem-solving reasoning engine of agents, connecting it securely to your local databases, and wrapping it all up in the perfect memory structure, what kind of proprietary internal business data could you unlock for your team? The potential here is just immense. Thank you so much for joining me on this explainer today. Keep experimenting, keep learning, and I really can't wait to see what you build.